Here is how we multiply two matrices. The number of elements in a row has to be equal to the number of elements in the column. Then we match them one by one and multiply pairwise. Then we add them together. And this is the element Cij coming from the ith row multiplied by the jth column. And the size of the product is R times N. Square matrix can multiply to any other square matrix. And the most important square matrix is this identity matrix, one down the diagonal, because they act like one. Take any other matrix, multiply to identity matrix, it doesn't matter which side on, you wind up the same thing back. And so they act like one. Two matrices that call inverse of each other, if they multiply, the product is this identity is equal to one. But not all matrices have has inverse. The ones that are invertible are called non-singular or invertible. The ones that doesn't have inverse are called non-invertible. Here is example of non-invertible. Notice because of 0, 0 over here, there's no way I can multiply any matrix and I will get a 1 over here to get to the identity matrix. So this matrix is not invertible. How do you get inverse matrix? Here's a trick. We take the matrix, we enlarge it, then put the identity matrix on the side over here. Then we perform row operations. So we switch the position. So we wind up with identity matrix on the side. So here we go, make it larger. I'm going to get a 0 here by multiplying the first row by -1, add to the second row, so I have a 0 here. Now I want to get a 0 over here by multiply this by -2, add to the top. And then I get the identity matrix now on the left-hand side. The matrix on the right-hand side is the inverse. You can easily check that. And we can use the inverse to solve this system equation. We put this system in a matrix equation, that is a matrix coefficients times xy equal to the numbers. And we set this like an equation, just like we did in algebra 1, but they're all matrices. Then we multiply to both sides of these two matrices by the inverse of these. And this multiplies identity. Identity times xy is xy. So but xy on the other side, I get the answer. So x is 14, y is -5. In fact, these methods, we can do this traditional, basically we imitate what we do in traditional algebra, a times x is b, then x is a minus 1 times b. And in particular, can solve general solution as long as the coefficient is the same. Given the a, b, then xy must be equal to these. Okay, so this is the matrix methods. Bye-bye.